Hello, we've just started off and now I'm unmuted. Adrian and Jonathan might join us today. Adrian mentioned that he'd be on point or a little bit late, and I just see Jonathan jumping in backstage. Jonathan, are you ready to come on stage? Yes, thumbs up. Okay, here we go. Let me just take the banner off. And Jonathan, welcome.
Hello. Thanks for having me.
So this is a bit impromptu, but I wanted to sort of have you along to get your opinion, or at least to bounce some ideas, because you and I have been pairing on stream for the on and off for the past few weeks, and we did a lot of our conversations are about composability, are about behavior. You know, is this implementation? Is this behavior? Are we missing something? Is this the thing I'm testing, or is this a detail of the thing I'm testing, right? So we keep having these kinds of conversations, and I figured it's worth having a focused stream on this.
Good.
To our live audience, welcome. As always, it'll take a few minutes for us to catch up on delay. Send us a signal that you're here. I see Adrian jumping in backstage. Hey, Adrian. How are you feeling? Not good?
It's okay.
For context, everybody got sick. everybody during Easter, everybody got sick, and we sort of winged it with are we healthy, are we not healthy, are we streaming, are we not streaming? Usually Adrian and I have our logistics meetings on Monday, and that was Easter Monday, so that also fell through. And it was a challenging week, but we learned a lot of new things. I'm glad you could make it. It's good to see you again, Adrian. As a streaming update, we moved our Wednesday episode to tomorrow. So for those of you who are looking for the platform as a service conversation, instead of yesterday 4 p.m., it's going to be tomorrow at noon, which is our news slot. Adrian streamed in the news slot.
So for all American folks, please set an alarm very early on in the day, somewhere around 4 o'clock in the morning.
The inspiration, I guess, the trigger point for this conversation was Kent Beck's recent post. I just linked it in chat, and I do believe it's not paywalled. So I will share it on screen in a little bit. But now yes, okay. How's font size? I believe font size is always an issue, right? It's not just me that's blind. Yeah, okay, there we go. Cool. We'll come to that later. So for those of you who are wondering, so today is about behavioral composability, specifically what that means in terms of testing. Jonathan, Adrian, when I say behavioral composability, composition, what comes to mind for you guys?
Jonathan, go ahead. So it does make sense to pass the word to Jonathan now.
I would say the thing that comes to my mind is a number of discrete behaviors that can be either serialized or parallelized or otherwise made into some larger behavior. I hope that's not too trivial of a description.
That is actually quite precise.
Okay.
I like that. Could you repeat? I would love to write it down.
I don't know if I can repeat that. I'll try.
So we can see it in the LinkedIn version. It's 20 seconds after that.
So I said something like it's a set of multiple discrete behaviors that can be either aggregated or serialized or parallelized or otherwise joined together to create a larger interesting behavior. Wait, to use a really trivial example, riding a bicycle involves pushing my right leg forward and then pushing my left leg forward. Meanwhile, moving my body left and right to make sure I don't fall down. Those are all discrete behaviors, right? Moving left and right is one behavior. Pushing my right foot forward is one behavior. My left foot forward is one behavior, so on. But if I do all those together in the right sequence, ideally, I'm propelling myself down the street on a bicycle.
That's really interesting. I like that. Adrian, do you have a take on this?
I just continuing on the take on of Jonathan, and I would even call it like it's really an aggregation of behaviors for for an overarching behavior, and those can then be aggregated again. So just the hierarchy until the point where it actually ends. So, and I think this is the point. So when we think only about TDD now, TDDs, often originate from the unit test, where you just have a very single thing. And we know that from front end as well, when you go into component tests, they are very similar, but they are more integrative, but it's not really an integration test, so something in between. But you have in a component very often multiple behaviors, which aggregate to the behavior you expect from this component. But you have several units inside there which doing different things. For example, if we have the component bicycle, you have the pedals, you have the handlebars, you have everything you need in order to do things. And those behaviors needs to be, handled and tested. Yeah, let's say against their behaviors, so the expected behaviors on certain levels. So if you go for the unit test, for the pedals, you only test, even there, pedals, as Jonathan already said, you have basically two pedals. It's not only one pedal, and you can't push them both at the same time, otherwise you would do nothing, right? So it would, depending on what leg is stronger, but actually nothing would happen, right? If you push two pedals at the same time, you're basically standing up. This is what you would do then. And in order to get it right, the expected behavior is to push left, push right, push left, push right in a right direction. And then the bike starts to move, and the overall, so the most, let's say the highest expectation of the component bicycle then would be that you actually need to steer it, and you get from point A to point B without falling down. And this is then the final result. And this is what we could express in tests. But then it becomes more complicated to write it down, but more precise for others to understand what's actually the idea behind everything. And I think this is the idea of BDD. It's not to just focus on the units, it's to explain what happens in between all those things and why are we actually doing those things. Would you follow me, you both, or would you say I'm talking nonsense right now?
I like what you said there with the idea of at the end, if it all works, the bike will get you from point A to point B, right? And I think from a sort of BDD, from a gathering requirements perspective, one might naively say that the behavior of the feature is to get you from point A to point B. But then that's really hard to test if there's many different ways of how to get you from point A to point B with a bicycle. I can ride it forwards, I can ride it backwards, I can push it, I can pedal.
How do you ride a bike backwards? I want to see this. But yes. But I think here we are.
You can pedal backwards, and something needs to happen, right? So
no, nothing happens in most bikes.
No, but the point is nothing. Like in some bikes, pedaling backwards actually acted as a brake, and in some bikes pedaling backwards did nothing, so it and
in some it propels you backwards if you have,
and in some it propels
the monobikes from the clowns, right, in the circus.
So this idea of you can't pedal backwards, that is also defined behavior. Like something predictable it shouldn't be undefined behavior. That's where I'm alluding with this.
Yeah, but this is definition. So we're talking about requirements here. So you need to have requirements in order to define a behavior or an expectation for a behavior.
Yeah.
So you can't just say, hey, or just do some behavior. No. The behavior needs to lead towards the higher goal, which is the requirement, or respect the qualities, but it is about the requirement. What is the actual goal? So we want, for example, the requirement is we want to ride the bike for 100 meters straight forward without falling down. So just that would be already make us, or let's say, or helps us to define and express it into a test plan in a BDD aspect, which can span over multiple tests.
at which point, like, would you, like, where is the boundary of this is too pedantic detail, too much detail, right? So at what point would you say
Depends.
you would need to define, well, the operator of the bike needs to be at least this high, this tall, and they need to have 2 functional legs and at least 1 functional arm. But we prefer 2 functional arms. So, so at what point does it come in? Because you would naturally assume that that's just everybody.
So this takes us into like the realm that it's adjacent to BDD and TDD, which is the realm of stories. And like we imagine that the user comes to us and says, "Hey, I need to be able to get from my house to my job." Right? And then, like, there's 1,000 ways we could imagine to do that. And for some reason, we decided a bicycle is the way we're going to do it.
Yeah.
It's fast enough, but not too fast, and it's not too expensive, whatever. We decided that after talking to the user that a bicycle makes sense. So let's build a bicycle for this user. And we could just go sit in our dev corner and imagine, okay, let's assume that the user has two legs and 2 arms and that they're 1.8 meters tall and whatever. We can come up with all these assumptions. But until we talk to the user to figure out what they actually need, actually this person only has 1 leg. Okay, maybe a bicycle isn't the right solution for this person, or they have 2 legs but 1 is crippled, or whatever, or they need to be able to do this while carrying a large box of stuff. So they have 2 arms, but they can only use 1 of them at a time. So now we need a trailer or something. This is where we have those user conversations that stories are meant to facilitate. I don't mean a Jira screen. Context. I mean the actual story, talking to users about the things they want to do.
Yeah. So, Jonathan, you and I had this conversation regarding a driver you were building for Go, for 𝗵𝐽𝐽. So for those of you who don't know, Jonathan is a maintainer, is a contributor to the 𝗵𝐽𝐽 library, which is a CouchDB driver written in Go. And right now what you're doing is you're building let's say, a utility adapter, which is allowing you to spin up 𝗵𝐽𝐽 with a SQLite backing, where you can run tests against it, right? So you're creating a driver that allows you to isolate a database to see, to use it in a test environment, to provide it to other people who use 𝗵𝐽𝐽 as their integration point. You would give them a 𝗵𝐽𝐽 maintained test double, essentially.
Right. So a couple related goals. One is that if you're writing a Go program that uses CouchDB, you could just, rather than using the CouchDB driver with a large Couch instance or in Docker or whatever, you could just do it in memory with SQLite. Another use case is for people who don't use Go at all. I'm going to distribute a binary that will let you start up CouchDB on a port or a CouchDB double, if you will, using SQLite, either in memory or on disk. So you could, even if you're writing your program in Ruby or PHP or something, it talks to CouchDB, you could still use 𝗵𝐽𝐽 during your tests, so you don't have to start up something heavy like a full-fledged CouchDB server.
And we got into this conversation of CouchDB has a certain interface. It can put, imagine a CRUD interface, right? But it's a bit more complex than that.
It's CRUD with a lot of bells and whistles, yeah.
Yeah, it's CRUD with bells and whistles. And then on the orthogonal, it's CRUD with bells and whistles. But in this particular case, it is SQLite backed. And then we were going to test that. But now we're no longer testing the bells and whistles. We were testing the SQLite backing. And what we found is that it was very hard for us to express testing the SQLite backing without the bells and whistles of the CRUD API. So our SQLite backing, for better or for worse, was heavily coupled with what seemed an orthogonal concern, which is the public-facing CRUD API, right? So when you and I started collaborating together, I immediately got this feeling of, isn't this like too far away? Like, isn't this larger than a unit? Isn't this more end-to-end rather than a benign contract test, or maybe even just an integration test, right? So we seem to be testing the integration side of the backend and the integration side of the front end. That feels awfully like an end-to-end test. Is this the simplest way of describing behavior? Is this the simplest way of composing behavior? Do we understand it? And I noticed that you also adopted writing test plans after our first few streams. So
yeah,
go ahead, Adrian.
Just regarding test plans, I had this topic today. I often ask myself, how far do you plan a test or express a test plan upfront? So imagine you have a component with several units inside there, and you want to write a test plan for this. How far do you actually go? And I personally tend to go in iteration. So I define an iteration, and then I make it green, I make it blue. I rethink, and then I go red again by extending the test to the next iteration. So I had that today, and we created in a demo a UI first, and then we're going into the logic, and then we refactored the logic. So 3 big steps in general. This is how I do my test plans, actually. How do you handle this? So if you go for test plans, maybe with a BDD now in mind as well, would you say outlining everything already is a good idea, even if it's only comments? Or do you think you should do it in an iterative way? And what does this IT actually stands for in those test files? Is it integration test, iterative test, integrated? I don't know what it is actually meaning.
Okay.
No, because this is my test plan. I actually write ththose in those ITs down.
So my answer is I don't have a system in place really on this particular project, because it has a well-defined API. It is pretty easy to look at the Couch documentation and say, okay, I need these end behaviors for this endpoint, or this number of options, whatever. So I can just easily turn that into a to-do list. Like, I need to make sure that I add support for this option and all of its variants, or whatever, all of its values, right? So that's an easy to create sort of test plan. And I've done that. As I start with each endpoint, I make this sort of a to-do list at the bottom of my test file where I add all these options. And then as I'm going and I think of new corner cases, I add them as they pop into mind. So a good example, after the last time Adrian, I was streaming without, not Adrian, Dennis. I was streaming and Dennis was in chat, and but he wasn't on the stream.
Yeah, it was this Monday, and I was super sick, and I couldn't.
Oh, no.
I could type but not speak.
But he was quite interactive, and I don't remember exactly what happened, but he triggered something in my mind that caused me to go afterwards, after the stream, and I did some more editing. And as I was doing that, I discovered that the same case I had covered on the stream needed to be covered in 3 other places. So I just added that to 3 new to those things, and then I think it was last night or the night before, watching TV with my wife, I went through and I hammered those out one at a time. So that's an example of it. I just realized this corner case, and this applies to other endpoints too. Let me add that to my to-do list so I don't forget. And then tackle it as I have time and as I'm motivated. Some of those options I will probably never add tests for, because I'll never implement those particular features. They're sort of corner cases, or they're performance optimizations I don't care about for this use case, or whatever. They're features that Couch has that I'm just not going to implement, and that's fine.
Replicate
on my list.
So that would be the equivalent of, there is a feature that supports multi-terabyte slow replication across
a really simple example is the put. When you put a document, you have the option to specify batch mode, and batch mode queues up a number of puts and then commits them all at once on disk. Which makes sense if you're on a really busy server getting thousands of requests per second or something. So for a little test thing, I don't need to add that complexity. It'll probably make my code slower rather than faster. For something like this, it's just something I don't need. So I mean, it's still on my to-do list, kind of as a documentation that this is unimplemented, but it's probably never going to be implemented in this particular backend. If it ever is, I'll have to have a convincing case that it's useful before I add it. I'm not going to just add it because it seems like fun.
So from what I remember, it took me a very long time to really take composability seriously, just because it is so difficult. It is
in some cases, yes.
It is very much a orthogonal layer on top of testing is already difficult, and expressing your behavior is already difficult in like a very clear way. And then saying, okay, now I also need to first of all, if my test scenario is too large, I also need to decompose it, right? Decompose in this context meaning split. And I drew a lot of inspiration from the way the Agile community splits tickets. So Adrian, when you asked, what is my strategy for writing a test plan, I use exactly the same heuristics as I would for splitting stories, splitting tickets. I would read one, have a conversation with somebody, and then decide, okay, that's actually a lot of cases. That's too many acceptance criteria. I will create a separate ticket for each one for the purpose to just brain dump and then say, which one would be the most natural starting point? Would it be meaningful to start in the complicated case? Well, no, because you'll need to cover the null case, and then this is where zombies comes in. So I would generally split tests up. I would brain dump 3, 4, 5, and then try to describe them. Well, what exactly does it do? Does it do only one thing? Well, no, there's a few scenarios. God damn it. Okay, write down each scenario. And that works to a certain degree. That is not behavior composition. That is just me dumping down all permutations of behavior. And I think this is where the real craft of today's topic comes in. But I basically would do test decomposition and test planning instead of project planning. Like, to me, those seem to be equivalent activities. I would much rather define acceptance criteria and BDD tests with a team in like a short 10-15 minute pair programming session, and then commit those and then share those and then create tickets out of the to-do list rather than create tickets and then figure out, okay, wait, this is one test each, but not really, and then get lost in the weeds. And to answer your question regarding iteration, I would always throw away the first test plan. The first test plan is for me just to start somewhere, unless I really know the domain well. And to give props to Jonathan's approach, Jonathan, I also need to mention that your user-facing behavior is not exploratory. You have strict requirements. Your public-facing API is extremely stable. So there is zero. You're doing a backward compatible.
There's a very small amount of flexibility I have. They're like wording and error messages and stuff like that. It's about as far as I can go.
Yes. You have a strict API, strict precondition checks, strict post conditions. What can be a side effect? What can be a side effect? In certain cases, even timing constraints. So you are following a strict spec, and you're writing tests for a particular flavor of implementation, which is very difficult. Plus, it's a database. Right, so we're not using Postgres, we are writing a Postgres, right? So the idea of what is a developer test and what is an integration test is slightly skewed because our application's domain is state management, right? So that's it is external state management to some degree, right? So that, to me, that's always difficult, to write tests for a database. Because then
just imagine trying to write a test suite for your test framework.
Yeah.
How does Cypress write tests for Cypress, right?
With an older version of Cypress. I don't know. I guess at a certain point you can, I think for each compiler, even each languages, one of the litmus tests is, can you write the compiler for the language in the language, right? So that's usually I think that has a rule in compiler theory, but I don't remember exactly what it was. Who had some comments prior to today's episode? Those of you who are live in chat, please make yourself known if you have any comments, have any questions. Now is a good time before we put the article on screen. I just want to read out a few comments that we already had. So I dropped a comment in linked. It is Kent Beck's article on TDD's missing skill, behavioral composition. James Galian mentions in a conversation with Kaloyan, one of our regulars. James mentions, I have to sort it by
James
day.
Galian.
Galian, is that how we pronounce it? Sorry.
And first entire year I pronounced it wrong as well.
Okay. James Galian.
Hello, James.
Hey, James. James Galian comments, Kent's article claims data-centered code has behaviors. A rock doesn't have behaviors, even if we make it our imaginary friend. I don't consider a collection as having behaviors, as it isn't pure. Its final output goes to state, to memory, which is an external resource. Jonathan, this is actually very similar to what you and I were discussing on Monday. James mentions data classes can be faked, external resources mocked, both sent into behaviors, right? So this idea that namespaces capture higher order functions and behavior, and the higher order functions are the types of behavior that this sort of namespace, package, file, module supports publicly. Both sent into behaviors, he says. Here we continue. And only the results of behaviors should be tested. Now, I'm not sure whether results of behaviors implies return value or whether there's some inspection of state. Never spy into behavior, or we are back to smallest unit test and not behavioral testing. This pattern works really well for TDD, but that I agree with. James also says, a behavior that needs an external resource may not technically be pure, but the actor model enforces proper safe usage of state and external resources. And that seems to be what we were doing with Jonathan. Okay, and there's some commentary with 𝐬𝐞𝐜𝐡. 𝐬𝐞𝐜𝐡 mentions, we got some praise for the stream. There we go. And James also started the whole conversation with saying data classes and external resources should be separated from behaviors. Otherwise, everything is a behavior. And that can get quite confusing and unorganized. So that's the comments we have so far on the stream. Do we have anything in chat? No, nothing in chat yet. Does chat work? Those of you who are live, let us know if chat works. I will put this article. Yes, we have one from Twitch. No, that's spam.
No. That's
spam. Okay, that's spam.
Well,
Nice
that means
to
it
know.
works.
Thank you, bot. Wait, did the bot understand me? And oh man, I'm getting so. Did the bot understand what
we can invite the bot to hot join.
But that does look like spam. So the article is this. I'll put it on screen now. So Kent was responding to a comment by 𝗪𝗵𝗵𝗺. And thank you, Artem. Sorry for putting you on the spot, but thank you for kickstarting this whole conversation. Artem comments that TDD is a broken practice. It's always been broken. It's broken by the definition of it. Its biggest merit is the encouragement of testing, but that's about where it ends. TDD implies writing tests before writing the code, the implementation code. So what's broken about this, Artem? You write tests to describe the intention behind the system, how you expect it to behave. TDD heavily implies that you should know how the system behaves before even implementing it.
Yeah.
You should know what you're doing.
So my biggest complaint with this is that it thinks that TDD is implying things that TDD explicitly says.
Okay.
Well, but I agree that you always should, before you execute anything, it's not about TDD only. It's everything. You can't start a project without knowing what you're actually going to do. And if it's only the first iteration, it doesn't matter. So the next practical steps needs to be covered by requirements and qualities, always. And you need to have a context in which you are. So we had that with a bike. So if you don't know what to do with a bike, so do you want to just, as we said, ride your bike 100 meters straight forward on a road? This is one thing as a healthy person. Do you want to ride a downhill track in the Black Forest? Is a totally different story of things, of requirements and stuff like this. There's a lot more flaky because people might die on the way down, and this is extremely important to understand. And this is why I personally, and TDD becomes more and more a topic in fellowships. For me, actually. Same. So people asking more and more about this topic because the result is not really Kent Beck, I'd have to say. The result is the own history of the companies or teams. They have created a lot of legacy stuff, as we all did, and all the legacy stuff was traditionally not tested in the way like it should have been. Sometimes too much, so people removed the test because there was a fatigue, or sometimes not at all. And TDD is an approach where you think about how you actually test things, how you build things, how you structure things. And what you see often when practicing TDD is not only that you understand what you're going to do, it is you design the software differently. The design of the, let's say, design principles, you apply them differently, because people say, I don't want to have long tests, so long test files. I don't want to have this and that. Long. So if you see that your test files becoming more and more complex, you know that the tests are actually representing the component, the unit, the function, the class. So this is a sign that the class became too complicated and might have too many side effects, right? So you need to refactor that into smaller pieces. So it helps you to first of all understand what is the general direction, the behavior, the overarching behavior, the goal, and how you actually implement this to first meet the requirements and long-term be able to maintain those requirements. And this is where I see TDD as the tool how to go this way. Because if you don't apply TDD, you actually build legacy. And I don't have numbers for this right now, but this is what I see everywhere. This is 100% for me. So in every company I join, in my own products we build, no matter where I take a look, it is always the same. So if you haven't done your tests beforehand, the chance is extremely high that you end up with a legacy system, because you built something which you may be testing later. Maybe, because test last development or test somewhere in the future development is not accurate. You know, this is based on personal resistance. There we're coming back to the war of art. Kaloyan, there's the plug.
There's the plug.
There's the plug. It's important to mention that it is about, so not testing before you're actually building something is a form of resistance, is a part, it's a part of your ego, because you want to be faster in what you do. In reality, you fool yourself in that moment, because it will hurt you. And then we come back to the discussion of technical debt. I write an article about that, because technical debt is actually not a debt. It is just damage you do twice, and you can't really revert that. So you will pay in the future basically again for something you have done wrong in the beginning. And the beginning is right now. And if you don't apply TDD, and it can be like, so we can argue if you really need to write the test before the component, or you do that simultaneously. The idea is that you don't do that somewhere in the future. You do it right now in the first phase before you commit. The best way to do that is to write it first, because this is clear. You don't need to argue about that with yourself or something. It's clear. But it is about to think before you do. And I had several videos about this, like understand before you do. And this is the same with architecture, the same with how you set up your team, what tech stack to use. You need to understand everything before you actually do it. You don't need to be a master in it, but you need to have a rough idea in which direction you want to go, which are the limitations you have, all those kind of things. And the behavior, we're talking about behavior today, is actually exactly that. If you don't know what the behavior will be or is expected to be, how can you actually build something?
One of my distant relatives is a carpenter, and he's lost like 2-3 fingers, and he always says, measure twice, cut once. Right, so sort of measure it again, you double check your numbers, and then cut, right? Once you cut, it's, and I think this has, testing after is fine. It's below standard, according to my standard, but it still produces a test. However, I find, and this is through my observations as coaching teams who struggle with this, tests that are written far after implementation are never decomposed. They generally fall into that tall, complex testing harness that is getting really close to end-to-end. and then they got really scroungy. It's like, oh wow, like one thing was hard to test. I'm glad we didn't do this earlier because it would have delayed the launch even further. Now we have sort of downtime. Now we can a little bit test cover. But the test coverage is never of high quality, and the test coverage is never sufficient. Because the behaviors were never decomposed, and how to decompose the behaviors was lost.
Yeah, if you do test after or test last development, you tend to test like in an end-to-end test. So it is a little bit like you try to define very rough outcomes and test against those. It's a little bit like having a component mounted and test that the component is there. It is a little bit like very shallow in this case.
It's a smoke test. It is. You just want it to fail fast, but it won't really tell you what's going on and what the expected behavior is.
And especially
to take our bicycle analogies a little bit too far, most test after tests I see amount to let's attach our rocket to the bicycle and shoot it down the thing and see if it's still standing when it gets there. Whereas if you did it, test-driven bicycle, you would have tests that test: does each pedal turn appropriately? Do the handlebars turn appropriately? Is the seat adjusted? Can it be moved when necessary? You test each individual component, and as a result, you would know that the bicycle moves appropriately down the thing without attaching a rocket to it. When you attach that rocket to it and it doesn't make it to the end, you don't know if the problem is your rocket or the bicycle or something about your test conditions. It's just a very flaky test. And sometimes, maybe if the bicycle gets to the end, that's probably better than not getting to the end. But that doesn't necessarily mean that the pedals work right either, because you didn't propel the bicycle with the pedals. You only tested parts of the bicycle in that scenario.
And there we are at the let's say now get to the next behavior, the next story. You need to ride the first 100 meters straight away, but then you need to ride through a town over several kilometers, and you need to get down from the bike. You need to do some things. That the point is, if your pedals aren't working, but you get the first 100 meters, it doesn't tell you if you would be able to do the next step. Of course, this must be tested differently, but you need to make sure that the requirements which led you to the idea of, hey, I want to ride a bike properly. So this is the requirement. I want to ride a bike like it is supposed to be ridden, and to be ridden. I think so. And you know what I mean. It is a little bit like you need to make sure that this test covers this as well. Not only that you have made it. This is the end-to-end test. You need to have this test to have an idea of if this actually worked. But you need to have the details in order to be able to maintain the component later, to refactor, to extend. So if you want to add something to the bike, then you need to make sure that this is actually still working. So you want to exchange new type of pedals. You want to, I don't know what you can do with a bike actually to extend, but it's about that. So if you want to change something later on, you need to have this fine-grained testing, which gives you feedback that you actually haven't broken something.
So let's continue with the article. Any comments before we move on to the next section?
My biggest comment about this article is I love the way Kent Beck is able to respond to people with humility and respect in ways that I
appreciate that as well.
with.
And that's the part. And I even
patience.
I was very much low energy and in a bad mood when I was sick, and I got hooked and baited into so many playing wars on LinkedIn. I really need to turn it off.
Sometimes LinkedIn is not the place for having a good time, to be honest. Because
I need to be very wary of, I'm getting pulled in. Like, I'm not being challenged in a way where somebody wants to learn something new.
Yeah.
It's just a flame. It's just trolling, essentially. It's just somebody disagreeing, and then we're trying to prove each other wrong. And it's always a waste of time. And I find it sometimes difficult to detach from that. Anyway, let's continue. Kent comments, I appreciate Mr. Zacharchenko's extensive critique of TDD, even as I have some reservations regarding his language. He tried TDD. He thought about it. He put his thoughts out there. He knew he was going to get a reaction, and he did. 300,000 views, 160 comments, 190 reposts, 1,000 likes. I'm guilty of this as well. I've sometimes said silly, controversial things about pull requests, trunk-based development, continuous integration, TDD, testing, databases, refactoring. So I get it. I get it. I felt that, you know. He describes his programming workflow, which he describes as prototype into iterate into test. So Adrian, this would be test after test, maybe later, right? It doesn't sound like a horrible workflow to me, aside from the inevitable temptation to skip testing. But his description of his workflow and his struggles with TDD make it sound to me like he is missing a skill that I and other folks who use TDD have taken for granted all these years.
Yeah.
Know that when I say he's missing a skill, I don't mean he's a bad programmer. I am missing lots of skills. Nobody, as 𝗪𝗵𝗵𝗶 put it, has a full bag of golf clubs. There's a thing that I do that if he was able to do it, he wouldn't talk about TDD the way he does. None of which is to imply that he should use TDD or learn the skill I'm about to describe. And of course, the skill that Kent Beck is referring to is behavioral composition.
Mm-hmm.
Comments before we continue?
I agree with Kent's analysis. I want to just make a cautionary note to myself and anybody listening who cares to listen to me. Artem made this claim that TDD is broken by definition.
Mm-hmm.
I think that is objectively inaccurate, and I think that Artem, if he would take a moment to think about it, could figure the same out for himself. We all make these sorts of claims, though. We try something,
yeah,
it's terrible. ORMs are broken by definition, or
yeah.
Web frameworks are broken by definition. You know, whatever. We do this thing all the time. Just
Angular is terrible. Use React instead.
Whatever.
But Angular is terrible. Sorry.
But by definition, or just
by definition. By
By definition.
By definition. Sorry. By definition.
Or
Let's go
waterfall. Or waterfall style.
or waterfall, or whatever.
Yeah.
The thing is, now some things are probably not broken by definition, unless you mean a broken bicycle is broken by definition. That's why it's called broken bicycle. But a lot of most of these things have some context where they make sense.
Yeah.
Mm-hmm.
And I think Artem, even at the end of his comment, his last paragraph says, if you look at the full tweet, you don't see it on Kent's thing, but if you look at the full tweet,
Can you scroll up?
The last, you have to click on it, and then it pulls up. The full thing is like a full page long. But the very last paragraph says, "Don't be discouraged. Adapt the practices that work for you, even if it's TDD." So he even admits, at least in theory, that TDD might work for someone, after saying it's broken by definition at the beginning. So I think if he took a moment to think about it, he would agree that TDD might work for some people and therefore isn't broken by definition.
Thank you, Jonathan, for bringing this to my attention. I did not know that the post could be... I was not aware that the post was...
In general, the very same pattern, what we see here right now, we see on LinkedIn every day. So it is like, if you scroll through your feed, there are several content creators, in quotes, which are not content creators, which are just reactions. Let's say they talk about things in a way that they try to end those things, that try to be the resistance to some trend, or let's say I don't want to be the person who jumps on the hype train. They call it the hype. TDD, React, those things, those large things, let's say, they are not a hype. No, they are not. They are some form of standard. They might not be the industry standard. So React might be the industry standard, but TDD is something which is a standard in its case, but might not be the industry, because most people I know don't use it right now. But it is a defined form of practice. You can read about this. There is literature, a lot of that. There are a lot of people, smart people, talking about that. There is a lot of, there is basically science behind it. So people treated or created scientific approaches based on TDD and take a look at it, created reports out of that. This is something you cannot just simply call like it's broken because you have tested it for yourself for some hours. So it is not really working. And another thing is, I am doubting that this person, I don't know this person, but I see this so often, that people don't really use those things, but they make those claims. So I just make fun of Angular. I never used Angular myself, so it is not bad. Just it is not. My team used it, and I just took a look from outside, and we all disliked it. But this was just a personal thing of us. It still works. It's one of the largest things out there, right? It was one of the first reactive frameworks and all this kind of stuff. Without Angular, there would be no React. And we need to think about this way. So it is wrong to just practice something for a short while and then suddenly do something which is clearly a Dunning-Kruger problem. It is like you think you have understood everything and every facet about this context, and you start to judge it in an absolute way. That doesn't make sense. This is the opposite of being a professional person. This is being greedy for impressions. This is being greedy for likes. This is, I want to be controversial in order to get some attention. Because arguments and discussions, heavy discussions, brawls on LinkedIn, those get your attention. But this is nothing. So if you don't do that on conferences, I never ever see on a conference where people are in front of you talking like that. Never. It is you don't do that.
And I just checked Artem's epicweb.dev website. He does speak positively about testing in his other articles. So this seemed to be a one-off sort of tantrum breakdown, or a little bit of, let's say, venting about some form of frustration. And I can see what drove Kent to respond to this, because if I highlighted a section here, if you see it on the screen. In fact, I can spend days experimenting, writing an MVP until I even begin to grasp what parts of my system should be and what I expect from them. So this, to me, seems to be that he's doing some form of exploratory design, exploratory business requirements gathering, prototyping, and then, to a large degree, what he will be testing would be some equivalent of integration or end-to-end test.
But this is not professional engineering. So this is if I write prototypes, I write prototypes. I don't write production code. Those are two different things.
I don't want to explore that venue just yet. I just want to continue reading this for now. He says, I don't see TDD as a viable approach in fast evolving systems like the web. So I would emphasize here, for the type of, for the way how he just described building a system, right? So experimenting, writing an MVP until I begin to grasp what parts of my system should be and what I expect for them. Of course, TDD doesn't work for that because you don't know what you're coding. Because you don't actually know what you're building. You're exploring what to build. You are exploring your entrepreneurial energies, product exploration, product viability, product testing, perhaps, pretending you're the real user. And then once you caught on to something, then you start defining behavior, and then you start testing in whatever is left of the code. And that seems to be just a chaotic way of working, which might be more entrepreneurially styled, but I wouldn't call that specifically engineering. Because he did mention that the negative aspect of TDD is that I've seen teams discouraged if they fail to follow it, right? So what he comments is that he met people who thought the only way to test was TDD. So if they couldn't get TDD to work in what I assume to be a legacy system, they would stop testing altogether, which he considers a bad practice because he does actually advocate, guys, test your stuff. If you check his other articles,
but there's so much wrong. There's so much wrong here.
But there's a disconnect here.
We're mixing here, this article mixing things. So if you would follow this article and take it as something which would be true, which isn't, in my opinion, then we would have let's put it differently. The reasons why I have many fellowships and helping other people is because people did it like he's suggesting it. And the problem is that you're actually mixing two things here. The very early design phase this person is describing in the article is actually the part where you gather requirements. It is not the programming part yet. So some people tend to do this already in programming, especially the typical software developers which came in an entrepreneurial area, up and running, and they say now, okay, I do that the developer way. But in all other projects, especially when you work with larger companies, no one is just start to type something and take a look if this is the right thing. So you have people, the developers are hopefully part of the process, but oftentimes not. So you know already from the business side, the product owner, the designers, they have defined something which could be an option or a test for the market. And oftentimes they have created MVPs just with Webflow or something like that, or with an entire other company, an entire other team. And that exactly. And then you get to the point where you know what you want to do. And this is one of the ingredients of TDD, that you can express that before you start. So if you don't know what you want to do, and then you blame that TDD is a bad practice for finding requirements, yes, it is, because it's wrong. Point, period. False. This is just a failed post in this case.
I would connect the dots, however, because he says, if I follow TDD faithfully, hang on.
So I want to point out, I mean, Kent makes the claim, he appreciates the critique. He said he tried TDD. I don't believe that. I don't think this person has ever tried TDD. He's just criticizing based on assumptions.
So what I wanted to connect is exactly what you just commented on. He says, if I follow TDD faithfully, I will be wasting my time writing tests that I will eventually throw away. However, he does say, I don't see TDD as a viable approach.
And I can spend days later, I don't do TDD.
Yes. And he says, in fact, I can spend days experimenting, writing an MVP until I even begin to grasp what parts of my system should be and what I expect from them. So he says he doesn't do TDD because he'll end up wasting time throwing away tests. At the same time, he says he likes experimenting, sometimes even spending 2 weeks on something that he doesn't understand. Right? So this is where
that's fine. If you're in that experimentation mode, learning something, don't do TDD, but don't deploy that code to production either.
Yeah,
I just wanted to connect those dots because this is the same concept. Like exploring it is exactly the same. Sometimes I will write a test to see that I'm going down the wrong direction. This is too hard to do. I misunderstand the problem. Okay, and I want to go back. I don't want to focus on Argent too much.
I want to call out something I discovered as we've been chatting here.
Okay.
He mentioned that he has some other good posts about testing. I'm going to cautiously call this astroturfing.
What is it? What? Could you explain the term?
Are you familiar with the concept of a grassroots effort, grassroots movement?
No.
Grassroots movement is like the community comes up and does something from the ground up, right? That's grassroots. It's probably an American term, but grassroots political movement wouldn't be led by a politician; it'd be led by the community.
Okay.
Astroturfing is when you make it look like that, but it's not really that.
Okay, so it's PR.
PR.
Okay.
So I'm cautiously suggesting that his post and his articles may be astroturfing, and what I mean by that, if you follow the links to his other articles, The True Purpose of Testing and Golden Rule of Assertions, it is a brand new website called epicweb.dev. Every article on it was published on March 27.
A week ago, yes.
Although I'm not 100% sure of that date because his tweet that links to those is older than that. So some of those dates may have been updated.
This is bordering on.
But it looks like this is all
investigative journalism.
It looks like this is all an attempt to get eyes on their website, which is promoting a conference they're running, and potentially a web framework called Epic Web. I can't tell if it's a framework or what it is.
I think it's courses.
So anyway, the point is, if I had just launched a website about front-end development and I didn't think TDD was important, Why not do some crap posting on Twitter about TDD to get eyeballs on my stuff?
So you're saying this is virtue signaling, and this is just to create hype for?
I think it likely is. I think this post was to draw attention to his 2 other articles about testing, which in turn were to bring eyeballs to his.
And just to be clear, none of his other articles about testing ever mentions TDD or continuous integration. So take that with a grain of salt. But I would like to continue.
By the way, none of that to say that it's necessarily wrong or inappropriate way to do something.
I don't want to witch hunt. Like, our thing here is coincidental. I'm grateful for his work.
Yeah.
In that we got to, his commentary sparked Kent to write about this, and I'm more excited about Kent's work here than it is about decomposing Artem's work. So I just don't want to propagate a witch hunt.
But I want to return to the point that you wouldn't do that on a real conference in front of real people where you have something to lose. The point is, what there is written is simply dangerous for companies. So it is about money, it's about existential things. The practices we're talking about are most likely small to medium-sized, maximum medium-sized businesses. It's not about large businesses, they don't work like that. And the small businesses often tend, especially the startups, to be as fast as possible. And they often mix the very early design phase with the actual design phase in iterations. And I see a big problem here. And I see so many people, companies, struggle in such a heavy way with that problem that I simply cannot just say that, hey, thank you for this great post. No, there's no thank you for that. This was a mistake to post something like that. And this is one of those things where people have their egoistic intentions. They want to create some form of attention for something. They will have something from it, despite it, no matter if the actual intention is good or not good. And engineering, and I have a specific credo for engineering written down, and one part of the engineering credo is one of the traditional ones, to not harm others. And I would never write something down where I think, or I'm not 100% convinced that this won't hurt other people. So it always can happen that something is not working for someone. But if I know that I post something which will definitely hurt other people because I promote in that moment that the early design phase should be part of the production phase, this will end up in problems for you and your company. Either you make it and become rich and it's good, or you fail and you will be bankrupt. There is nothing in between. Those companies all stuck on some point. And this is what I cannot do as a software engineer. So for me, this has nothing to do with software engineering. And this is what I want to point out. And I'm very clear about, and I had my posts, we had that on stream already. I am very picky about that. So engineering is a responsible, a mature way of doing software development. It is not just I do my thing and my way or the highway, or I don't care about others. This has nothing to do with engineering. Engineering is to do something for others, for the higher goal, disconnected from your own ego. And this is what we don't see in this post. And I think this is one of the things which bothers Kent in this point, where he wants to point out something with that you actually miss a skill. I personally think there are a lot of skills missing here at this point. And this is not only one skill. And I want to be precise about that, because LinkedIn, for example, we are streaming on LinkedIn right now. There are many people, it's full of those people.
This happens all the time.
Yeah, who basically they need a job, they need to have something, new contract, something like that, and they post the way it brings them the most value. And we need to have a competency for that as company owners, as developers, as juniors, as seniors, to understand what is right and what is wrong. And the best thing to take a look at this is, does it hurt others, or is it actually something which helps others? So and this for example, to when you read about TDD, and you can't just say, "Hey, I know, so I will judge TDD now," without not having read the book of Kent Beck, the original idea, have to 100%, or you can say that I was able to 100% understand the idea of TDD in this case, of BDD maybe already. I have practiced it. I got feedback from my own doing, and then I start to make my first hypothesis about if TDD is the right thing or the wrong thing. But if I haven't done that, I just experimented a little bit in my experimentation phase. This is nothing which gives you the right to make a judgment out of this. Because this is, who is doing that in a scientific approach? When you are an engineer, you work with applied science. This is what you do. You're not a craftsman. This is a big difference. And what I see there is a typical craftsman problem. This is a person who says, "Hey, the way I'm doing that is the right way." This is what I see. This is craftsman. This is the behavior of the journeymans, of the people running around and bragging how good they are with their hands, with their bare hands. They are not thinking about the overall process. But if we're doing software, if we create software, we are in a team, we have responsibility for a product, the business don't understand really what we do, so we need to make sure that what we create won't hurt anybody. Instead, it will create value and reduce complexity. This is engineering in its nutshell, and this is not represented by this post, period.
So it sounds like at least Adrian and I agree that this post is just crap, but I'm still interested in digging into what Kent said. I mean, because we don't need to respond to that post so much. I'm still interested in understanding Kent's thoughts on behavioral composition.
Let's continue with that. Kent mentions behavioral composition. I'm going to call this skill behavioral composition. It comes in 3 parts. The ability to break a big, complicated behavior into pieces. That's part 1. Part 2, to break it in such a way that implementing and verifying those pieces implies that the whole behavior acts as expected. And number 3, the confidence to work this process, so that I'm not, 𝗪𝗵𝗶𝐴 around trying to figure out the next step, but that actually that this is a proven process that is guaranteed to terminate in the outcome that I want. That it isn't just me, rolling the dice and hoping for the best. The last part is really important. That's my experience of TDD is the opposite of his. You should know how the system behaves before even implementing it. We all have some sense of how the system will behave when we're done, or we shouldn't start. But using behavioral composition, I explicitly don't care how the whole system behaves in detail before I start. So let me repeat that. Using behavioral composition, I explicitly don't care how the whole system behaves before I start. I gradually record my expectations piecemeal in the form of tests and satisfy those expectations piecemeal in the form of changes to the code.
Yeah, but here we see clearly a difference in the mindset and the context where both people are coming from. So when you see this 𝗪𝗵𝗲 guy, 𝗪𝗵𝗲, I think that was the name, and it's probably, let's say, a small team, small business person. I know many of them. And Kent is definitely not a small business person. He's doing that on a larger scale with other people doing that on a larger scale. And you have this thing where you already know what you need to implement. And what is very important is that we should, as small companies, where my context is as well, we should learn to adapt those good practices and don't stuck with the crap of the past, which led to so many broken companies and legacy systems out there. This was exactly the case. Just start because you can. But this is not the way you should go. And I think if the point about what Kent and people like Dave Farley, Brian Finster, or you both talking about are the things where we try to help smaller companies, smaller teams, individual contributors in small companies to understand ways how to do things on a stable way in a long-term sense, and not doing that just for the next seed funding round or something like that. So it is stupid to build a system which is only there to get some money next time. If you do that, this is not software engineering. This is just crafting something to get some money. I don't count that as real software development, because this is not the development. This is building software. This is really, you build something. You just build it.
It's demo staging.
Yeah. It is rushing towards a goal. It's rushing. Yeah, it's basically stress-driven development, and this has nothing to do with real software engineering, real software development. And we see this in every line. So Kent Beck, what he's talking about is, first of all, totally right, and does work on all in the entire vertical of, let's say, company sizes or team sizes. This is a universal pattern which is working. But the other person is just working about, as you put it, let's say fast changing, or I don't know, you know what I mean. It's about fast changing software. But think about that for a moment. What in your software is actually fast changing? If you manage to change every component every week entirely, this is crap. Don't do that. You can't work like that. This would be a totally unstable or unstable system. You can't work like that. On some point, your components, your functions, your API needs to become stable. And you can't. You need to make sure that changes don't happen in a way that you change 70% of a function every time you work on it. Maybe for refactoring, but not changing the entire idea and the behavior. If you do that, you don't do software development, because you don't develop anything. You just turn in a cycle on stage one, because you never get to stage two in this case. So this is not development. And when you do TDD, you think in iterations. So by default, you go from stage 1 to stage 2 to stage 3, which are called iterations in this case.
You're going from a place of lesser knowledge to more refined knowledge. So obviously there would be some element of rework, but not full rewrites, not full reconciliation of the assets that were created.
It's not even WordPress development is like that. So it is a little bit like we need to
using WordPress as a derogatory term.
Exactly.
One of the most successful open source projects.
It was a joke again. It was a joke again. I need to disclaim it was a joke.
Jonathan, your commentary on composition? Like at least the 3 bullet.
Yeah, on the 3 bullet points, I think, in my opinion, it's the middle one that's the hardest one. I think breaking things down into small pieces it is a skill, but most people can. I mean, even if you just squint, you could say each function is a piece, right? Or each for loop is a piece, or somebody could do that sort of.
That's the common
decomposition. But to do that in a way where you meet that second requirement, I think is the hard skill.
Yeah.
And that's hard. Confidence is probably the easiest. I mean, you could have a false confidence very easily. A justified confidence. Maybe Kent should update his article, say a justified confidence to work in this process. Because I've certainly met people who have confidence to just throw code at the wall and expect it to work. I think it's that second piece that's so hard.
I think what this speaks to me is that this speaks volumes about decomposition and behavioral composition is part of the development process. You shouldn't expect that if the requirements were defined, that somebody went through large efforts to decompose everything to atomic pieces. That is unrealistic. That there is still composition to be done in engineering, in design, in testing. That it's very unlikely that a ticket, a story, a idea is already composed to the right level of granularity when you start working on it, right? So that this in some way could be avoided. He mentions the toy problem. The following isn't intended to respond to his criticism, but to illustrate the skill I'm describing. Okay, so we have a code example. I'll close in a moment with some thoughts on using behavioral composition in the real world. What are the behaviors of a stack, he mentions. So he says, is empty where we get both answers, pushing an item and popping it, pushing two items and popping them in the right order, popping from an empty stack, and optional overfilling a stack. Those would be, let's say, an initial testing plan for each behavior composed. And notice that some behaviors come in pairs. It's not the crowdsourced form of testing where I write something and then I need private access to check if I had written it. But the API is actually exposing a sort of symmetry. And 𝗪𝐵𝐴𝐺 mentioned this, that, hey, we shouldn't really talk about behavior in data structures like this, because there's, apples and oranges in terms of what is test, is the persistence part of the behavior, which is also part of the challenge that you and I faced, Jonathan, in your driver, right? Where we said, well, if the API's behavior is already defined, why are we writing new tests for the SQLite one? Why can't we just run the old tests that would end-to-end test the system for viability, right? So this idea of if I push it and then I pop it, I expect it to come out. But there's a difference in, am I using a JavaScript array? Am I mallocing all memory space manually on the heap in C? Am I doing some kind of weird internal curried function persistence in a more functional approach, right? So the implementation detail is omitted, and we're sort of trying to stick to behavior, but sometimes you do want to get the implementation details of this particular implementation covered as well. And I think that's what James was commenting on earlier at the beginning of the episode. He mentions we could prototype this and iterate and come up with a reasonable solution, or we could implement it one test case at a time and come to approximately the same solution. So he comments that the stack is so simple that you could just implement it and then run it against the tests, and then write the tests and run it against the tests. Or you could start slowly from each by writing down the entire list and then starting with one test, implementation, another test, another implementation, another test, implementation, and you could compose the final solution through a series of incrementally increasing test writing, essentially. Coming up with the list above is what I mean by behavioral composition. So he says, composition is not create a stack. Here's the API for a stack. He says behavioral composition is coming up with small scenarios that capture, that when you add them all together, capture the overall behavior of the system. And I find this definition to be really close to how I think about test plans, how I think about writing tests. Right? I always then look at the test plan and say, does this cover everything? Right? So does this adequately, does any of the tests tempt me to cheat? Right? So would any of the tests be unrealistic? Would any of the tests fail in a way that isn't integration successful, that isn't viable for integration? For example, if I can, sorry,
exactly, share it as a quote. That's good.
Stacks, let's say the size of the stack is part of the behavior. I can check the size of the stack. I can implement push and pop in a way that only the size changes. Right? I can say when I push, size increases. When I pop, size decreases until 0. I can implement the size behavior without implementing the persistence behavior. Right? I can push a variable and I can throw it away and push, and then I can keep track of the size, and then I can pop, and then when I get to 0, the size continues to be 0. So I can implement push and pop behavior with size without actually, right? So I can The temptation is to say pushing and popping returns the actual values. Because that's two different behaviors. Pushing increases size. That's how I would decompose it, right? I would say pushing increases size.
Yeah.
Popping decreases size. Pushing and popping happens in LIFO order. When I push two items, first I get the last one, and then the second I get the first one. Right? I would define that as separate behaviors. Because if I know that pushing increases size and popping decreases size, if I combine that behavior with the persistence behavior, then I would know that even though I didn't have to write tests for them, I'm not going to assert size in the LIFO tests. Sorry, it's LIFO. Yeah, so in the LIFO tests, right? And I'm not going to imply return values of any kind in the size tests. This is what people usually mean by tests should only have one assertion, right? Meaning that the behavior should be decomposed before you write the tests. Otherwise, you're testing multiple behaviors, and it's possible you didn't decompose it into its atomic pieces.
Yeah.
The dangers of hang on, yeah, Calvin has a comment. That middle part, Calvin says, isn't that mostly observation analysis, and you use that for modeling? This one. It's a good question. I mean, modeling of what, right? Because you might be designing as you're writing the test, but if you got the test, we saw this, for example, I don't know, Jonathan, if you watched it. We had a 99 bottles kata with a lot of different hot joiners. I think like we had 5 different implementations on screen at some point in like two back-to-back streams. And there was that constant temptation of, let's just make it end-to-end, right? Like I can define the end-to-end test. And let's just print all 99 bottles and let's test all possible scenarios. And I think that's what it comes down to. Like the 99 bottles lyrics follows 5 simple rules. So it should be possible to say, if I test cover each behavior, that should give me the confidence that the end-to-end test is implied to work, rather than me having to double check with the end-to-end test. Right? So it's coming from that idea of I should be able to describe what it does, right? So in the 99 bottles, there's this, the bottle decrements. Now, there's no implication of how that is done. It's just that, and there's a rhyme. There's an echo of the line. The last line resets the song, right? So then when I put all of these together, if all of them pass, they should produce the lyrics. But it's very difficult to, it was also a stringly typed problem. So there was, commas, where did the commas go? Where did the new lines go? Where did the periods go? So that might be implementation detail at that point. So I'm curious what you guys think about. Jonathan, you linked something in private chat. Is that relevant?
Yeah, it is. It's an article that has had a big influence on my thinking about testing. It's originally from 2010, although it's been updated last year. It's called... it was originally called Integrated Tests Are a Scam. Now it's called Beware the Integrated.
Wait, I know
Tests
this person.
Scam. Yeah, 𝗵𝐵.
Yeah, is it JB? Is he called JB? Is that?
Yeah, or Joe. Yeah.
Joe. Okay, JB. Okay.
Yeah. And there's a video accompanying it, which you can see if you scroll down just a little bit there. You can watch the video version if you prefer that over reading. But the premise is that it's going back to what we were talking about earlier, and it's really about decomposition in different words. That if all you really need are appropriate unit tests to cover your entire application. Using a slightly maybe non-standard definition of unit test. But like mathematically speaking, if you can test every component of your system, and then test that every component, that the integration between those components is correct, you've by definition tested your entire application.
So the temptation is to say, oh, but then that's bullshit. I end up writing a lot more tests than implementation. But that usually comes from people who haven't decomposed their behavior.
Yeah, the thing you have highlighted on your screen right there is the antidote to that.
Yes. Right. So I think maybe we should mention what happens when you don't compose behavior, right? When you don't get down to the atomic pieces. If you want a realistic, let's say, if you want the confidence that your system works in production, that means that you need to go through all permutations of all behaviors, of all combinations, of all branches of logic, end to end. Which means that if I
that's
have
on your screen right now, that's what you're sharing right now.
So that would imply
how many tests you need? 1 million.
Yeah,
1 million tests.
If we have 10 layers and each of them have 3 different behaviors, then that's 60,000. Add 4 branches, and that's 1 million tests, right? So it means that if I have, so 10 branches, right? So if I have 40 different rules, it'll take 1 million tests to end-to-end test cover the entire system. That's the idea, right? So 10 layers with 4 branches each should take about 40 plus 1 for integration each to test cover fully. That's the idea here, right? So that if we have rules, we test cover each rule, not the amount of permutations that you have. And people who are not serious about this generally have a lot of permutations, and they test one, and it gives them false line coverage, and they say that's good enough. But they don't know that there's a bunch of bugs lingering.
Yeah, but this is not testing, this is trying out. There's a difference between, so many people say I have tested my stuff, I just, I called it and I saw a response, and maybe I even write an expectation for this. But if you have so many other variations which could happen, it is not really testing what you do. It is just trying out one of them and saying, okay, this is one of those things. And I think I have that in nearly everything, in every session where we talk about TDD with companies. It's especially small companies. When you have a complex application, which is most of the time the case after a while.
Complicated orchestration or integration points or one business domain, but it touches 7 databases.
So how do you actually test but stay flexible and be in motion still? So how do you get the confidence that you have a well-tested system, but not fall into this idea of, hey, I have 100% test coverage, which is actually impossible anyway in complex systems. So how do you manage this? And I want to come back to, let's say we've discussed already with the bike. So what we need to do is some form of happy path, but not in an end-to-end test idea, but in a component or a unit test idea, where we really say that, okay, I have a component here which is supposed to do this and that. And if I have 80% of that possibilities tested, it is very likely that the other 20% are, let's say, at least 80% as well, which leaves you with something in between 5% of a test margin, which could still fail. And this is, for me, a threshold of where I can still say I'm confident to deploy, because at least for the context of small businesses, because we are not in a medical sector, blah, 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 stuff like this. So you don't need to have this extreme extra effort to fill this last 5%. And you need to be agile, and you need to, one of those traps is that you build way too many tests and start to tighten or harden a system with tests so much down or tighten it closer to that you actually have the problem that you cannot do something anymore. And I think this is one of the points this other guy criticized, that you can't do anything anymore, but this is already an extreme. So what you should find is a good balance. Software development is about trade-offs, where you still can say I'm confident and I can live with if something still happens. And if this happens, so there was evidence, there was a proof that there is basically something where my code fails still, or the app fails, then I put that specifically back into the tests. So if I get the feedback of one of the clients, this is the reason why we want to have small iterations and early feedback, so we can implement that and roll forward in this case and say, okay, we have test covered this now. On some point, and this is then the experience, this is a subjective experience, the experience report now, on some point there will be no problems anymore. So there might be still cases where the system could fail, but you never get to those points, because there is one specific thing. Just because you would have 1 million cases, how many cases are actually in reality really happening, reachable, right? What can the user, so when we talk about the API now, what is the client really consuming?
But it's possible that the reachable cases are a linear subset, not an exponential subset. That it's a small percentage of a otherwise power law growing problem, right? So I wouldn't.
Yeah.
Let me just throw out there, though, that most systems don't have 1 million possible combinations. They have a literally infinite number of possible combinations.
Yeah.
Because they aren't deterministic. They're not just a state tree. They're yeah. Most systems that we work on have infinite numbers of possible inputs and outputs, and code execution paths and loops and all sorts of stuff. That's called the Turing
Turing machine,
problem, right? Yeah. No.
It's the stopping problem.
Yes, that. Thank you.
Oh, okay. But yeah, it is.
I mean, I can give you an example. Yeah. I can give you an example, right? I can say, I wanted the live code today, but I don't think we'll get to there. But I can say, try something. Sorry. I can say, try something, catch E, and then I say, I don't know, console log E dot boom. I can write a test that covers this line, right? So I can get to this line and cover the branch. But that doesn't guarantee that I cannot send a E that doesn't have foo. Or that doesn't guarantee that, I mean, everything can be converted to a string, but it doesn't guarantee that if I do send it an E that does have a foo, that it doesn't have some weird side effect, or that it doesn't print some garbage.
No.
It just coverage, line coverage in this case, and even branch coverage in this case, just means that I got here once. But that doesn't mean I covered all cases. It's very easy not to cover all cases here, right? So that's what we mean by that. This sort of permutative nature is very much. It's a distraction if what you're looking for is code coverage.
In many languages, you might have overflows. Maybe you have an integer overflow.
Exactly. You might have overflows. Or it might be null. It might be nullable. Yeah. It might be nullable in unexpected ways. So the Kent mentions ordering. How do you know in which order to implement the items in the list of tests? You don't a priori. And I think Artem spoke about this as well. Practice gives you some sense of what to choose next. Sometimes, though, you hit a dead end where you can't see how to implement the next test. Then you can either further decompose the behavior or back up a few steps and choose a different next increment of behavior. He mentioned discovery. What about behaviors you discover as you implement? Add them to the list. And I see you doing this a lot, Jonathan, and I have to commend you on this. This is great. You start, we were refactoring something on your previous stream, and even though we weren't super happy with how the refactoring ended up, we ended up finding a few bugs, and then some of them we fixed, some of them we highlighted as, as we're refactoring, we actually made some assumptions, which turned out exposed bugs, and then we write those down to be test covered and fixed later. Add them to the list. One of the great joys of programming is how it shows you in the starkest terms when you don't understand something. He mentions, how does this play out in the real world? Sometimes it's difficult, or for the moment impossible, to decompose behavior in a way that satisfies the conditions outlined above. Recomposing the decomposed behavior results in overall behavior that satisfies our needs, and we are confident in the process. Okay, in those cases, TDD doesn't apply. Right, so TDD doesn't apply in the case where the decomposition of the behavior is impossible because the decomposed behavior is so synthetic or artificial or unrealistic that it cannot be recomposed. Right? So if I have a mocking library that is isolated from some weather station out there that uses the noise from the temperature node to give me a random generator, then it's very difficult to decompose that behavior and recompose it in a way that doesn't integrate. And I think you and I touched on that on Monday and on your previous stream, Jonathan, where we kept running into this compositional issue of, are we changing the behavior of the driver, or is there something unique about this particular implementation? Like, what is it exactly that we should be testing? Are we testing that SQLite is SQLite? Are we testing that the queries are correct? Are we testing that we wrote the queries correctly? Are we testing that the API responds 200 to certain scenarios? Like, where exactly is the compositional boundary, right? Like, what exactly is the behavior that is new or that we might be caring about? And it did seem to have a very much heavy focus on the integration part because we were writing a database driver. Kent mentions, when I've encountered such situations and coded ahead unsupported by tests, sometimes I've failed and sometimes I've succeeded, but I've always thought, if I wanted to be supported by tests as I code, how could I have designed and coded this differently? And I've often found a way I could have applied TDD if only I had known, right? So this speaks about experience in general.
Yeah.
There will be problems that you just don't know how to decompose.
You can.
You have to explore, but it's important to learn something from it and then do it better next time.
So what you can do as well, this is what I do often, and we have it specifically in one project, or actually two. No, it's one project with several apps, and there we have the ownership of everything regarding front end, so entire applications, but not the API layer. And it is oftentimes hard to test it because the API often changes without we are noticing it. So it is hard to use mocks and fixtures and all this kind of stuff because you test something which isn't the case anymore, or it is the case in one application because the version of this one, blah, blah, blah. And what you can do, exactly. So I tend to use in those projects, when I do, or I still do it from time to time myself, I tend to extend TDD to the end-to-end testing as well, which means that in this case, end-to-end testing is pretty fast, which means a end-to-end test, if you run it just one test, for example, with Cypress in this case, for a very specific area, it takes not significantly longer to run than the component tests. Which means that you need the API running for this. But what I do is to actually define in a test-driven approach the expectations in the end-to-end test as well as in the component and unit tests. That's a little bit much, but it does cover the exact problem I think I have understood in Ken's post here in this case. So I don't have control. I don't know exactly what happens. I can't really mock it. And I don't want to wrap my head too much around it because I need to have it testable in some place.
And you don't want to create a virtual service because the contract is not stable. The spec, the API spec that you don't control is not stable. They will
exactly. But what I want to do with TDD is, of course, the aspects of TDD we have just discussed today, to get early feedback, to think about what you actually do. But you can extend or expand this away from the actual unit testing you do up to the end-to-end testing, which is important to keep the end-to-end tests as less flaky as possible and as fast as possible, that they can actually keep up with your local environment and stuff like this. Of course, there are a lot of preconditions to make that happen because oftentimes end-to-end tests can't even be run on your local machine. But in this case, this is the case. We have there some. This is important for us to actually have it, and then you have it in control, because what you actually want to do is to have the confidence that your changes won't break anything and reduce complexity when you implement them. And you have that by having both tests in the test pyramid. Again, so you have it in your unit tests, you know the functions, the classes you use are actually working. You use that they work in the first integration step in components and hooks. MOX. In this case, it's React. And in the last layer, you have it not only with the current MOX and fixtures you use in the component area, but you have a final test which you have defined upfront again. So, for example, you want to you have some form of list items, and this time you want to make sure that several of those items can have an additional button, for example, right? And then you can expect that in an end-to-end test and react on that, as well as in the component test itself. You do it on two tests at the same time, and then you actually cover this problem. So if I have understood the problem mentioned correctly, but in this case, I have described this works well if you span TDD on the entire pyramid, which is often not done, because most people say TDD is about unit testing. And it is true, it is mainly about that, but you can, if you have modern environments where you have started it in the right way, you can put, or let's say include, integration tests in the TDD as well.
I'll contradict it a little bit. So one of the places I most use E2E or integration TDD is on legacy systems, where there's no test coverage.
As a smoke test.
Yeah, so I'll put maybe I need to add an API endpoint or something. I don't know what, but I can express that in an end-to-end test. It depends on the database and the API and everything running. I can express that in an end-to-end test. So I'll do that first. Now, ideally, that's not a permanent state. Ideally, that's a temporary state, and I later decompose the test and the capabilities down to smaller, faster.
But it decomposes your confidence, but it allows you to sort of squeeze some extra bit of confidence, but it doesn't decompose the behavior, which is really the problem, right? So end-to-end tests never really help you understand behavior and decompose it, but they do help you sort of squeeze out a little bit more confidence that at least something isn't terribly broken. But it might not actually help you to move faster.
Yeah, but end-to-end tests help you. For example, you have a page where you have several components. They do something. There are multi-select components, single select components.
Yeah, for example, you might have a checkout page. The checkout page has an iframe.
Checkout page.
When I click PayPal, I want the PayPal iframe to appear. That's
exactly. So you need to make sure that every of those single items are working for themselves correctly, and you need to make sure that the behavior, the different stories where those components are actually aggregated are working as well. So you can't cover this inside the component test. You need to cover this in a layer above, in an integrated layer. And this is what I just meant. So if you don't have the 100% control over this integration layer, and this is, I think, the problem we're talking about here, so you can't really do that with MOX in a confident way, then you need to have something which covers both. And this is what I just meant. It is an optional thing. You don't need that. But for us, it brought us significantly higher and better confidence and stability inside the project. It is overhead to work with. This is definitely the case, because as soon as you start to integrate into TDD, it becomes complicated and a chore to do. It is not nice anymore, but it is. Let's get back to the idea of engineering. I really like that, because we fulfilling the credo again, to make sure that things are actually working. So we are not as fast as we would just be to say, our component's working, we are now confident that it actually worked, and suddenly you get the feedback, it doesn't work under this circumstance. And you can test cover that as well.
So Kent Beck's test desiderata does cover this to some degree, and the episode that I did last week as well on the 7 types of tests also mentions this, right? So I mentioned that what you need is this separation of developer tests and integration tests. And developer tests and integration tests are extremely fast, and they can cover a lot of decomposed behavior extremely quickly. But God forbid, don't do all permutations, please, because it's not necessary. But it doesn't give you a lot of confidence, because it doesn't integrate with the real system. So they are deterministic. If something's wrong, it'll tell you exactly what's wrong if you trust them. But they have no guarantees that you're not in La La Land. You can test against MOX, but if your MOX are not integrating against some part of the real system, then all of your developer and integration tests are demonstrably wrong, because they fail. They pass for the wrong reasons. right? They pass against the mock, but they don't pass against the real system. And it's important to write them, even though you understand that that might be the case. But then you also need to test cover all of the assumptions you make about all of the fakes, all of the mocks through contract testing or through dependency testing, right? So I can say you're not allowed to import that library, which means that you would have had to solve it your way, right? So, or you can say this library has to depend on that library, or it can never depend on this library. It has to be independent of this. It has to have its own reductionist approach to it. Otherwise, we're building a distributed monolith, right? So that's, this often happens in, property sourcing. It's a anti-pattern of event sourcing, where I'm not telling you what the intent of change was. I'm just telling you this field changed, this field changed, this field changed. But now if I want to understand what the state is when a process finishes, I now need to listen to all events. And I'm just creating a distributed monolith. I'm not actually decomposing behavior. I'm just CRUD sourcing, property sourcing. And a lot of people do tests like that. They property test or they CRUD test.
Yeah.
If I set A to A, I want A to be A when I get it. And that's not a useful test, because you're not testing, well, why would it change? Like, why would is a user allowed to change this? How many times are they allowed to change this? What are the preconditions for change? Same thing with things like, you might have a tenant-based system, and if you're doing some kind of integration test or end-to-end test, but the tenant has to be logged in. But I don't want the procedure of how authentication is being and how authorization is being performed. I don't want that test to impact how I'm testing, because I will then need all permutations. Imagine you have checkout. You can check out on PayPal and Stripe, and you can be logged in through a user or guest account or Google OpenID. And you can have a shipping address that's fresh or a shipping address that's coming from your Stripe or PayPal account, but not your Google ID account, because it doesn't have an address, right? Now, it's very easy to say, oh, well, these are 3 rules and 2 rules and 2 rules and 2 integration points. But it's annoying to go through all permutations, because there's quite a few of them, right? Because it might be, how many? 3, that's 9, 2, 18, 40 permutations? It would be really annoying to maintain tests for all possible permutations, because then it also gets very difficult to know, well, when the test breaks, what exactly went wrong? Is it, if test case Google with PayPal, where this address is, right? And you notice that these texts are flaky because they have the word "and" in the test name. When this, and that, and this, and that, and this, and that, and then it has 7 expectations. Then this happens, and this happens, and this happens, and this happens, and this happens, right? That is the contrast to to no decomposition, right? So that is somebody who just end-to-end tests through unit tests, and that will be extremely difficult to maintain, and at some point it will break, because there will be something that has an asynchronous iframe or a reverse callback or an IPN or a PayPal callback, and it'll just jump out of the time frame of, let's say, a fast-running test. Or it might require a publicly visible domain name, and it won't route to localhost, right? And then that will become then really hard to scale.
Yeah.
𝗏𝐿 mentioned, shouldn't end-to-end tests follow the 80-20 rule, so you don't have to cover everything. You focus on the vital few cases that probably 80% of consequences come from those. I wouldn't even do this. Like, this is coming from the bullshit test pyramid advice. But you need to understand. Hey, hang on. Jonathan.
Yeah.
You're talking to me in private chat. Just tell me to shut up and ask the question. Wait, hang on. So I wouldn't do, so in response to 𝗏𝐿, I wouldn't do this whole 80-20 rule.
No, I agree.
I mentioned last time, what is important? Developer tests and smoke tests. If you have no tests, please start with smoke tests. Start with smoke tests, because you will be refactoring the system in order to make it testable. So the smoke tests will help you see if you've broken the system. So
yeah, but he's mentioning end-to-end tests in particular.
I know,
not the testing pyramid.
All end-to-end tests are smoke tests. End-to-end tests do not assert behavior. End-to-end tests should only regress failure. right? So end-to-end tests should tell you this artifact is not viable for production. That's what smoke tests tell you. I run the smoke tests, and it gives me a really quick failure. That's the point. But if it's green, there's no guarantee that it works.
Yeah,
well.
of course, but I think what 𝗫𝐿 mentions is on some point you need to define for yourself if you have this confidence that this smoke test helps you to get this information or not. And for this, you need to make 100% is not feasible. But what is it? And this is what I meant before. I think that it's probably mentioning that because I mentioned the 𝗵𝐴 principle. And my idea is that 80% test coverage doesn't mean that 20% is failing. It does only mean that we have covered most. So on some point, the idea is that you have a good feeling. So it's not like you need to measure 80% now and the 20% is not covered or something like that.
I see.
It is more like that.
How I understood it was that there should be 20% of your tests should be end-to-end.
No. This is not about that. This is how much. How far do you go with your tests in form of assertions inside the end-to-end test? This is how I understand that.
Okay.
So I have a slightly different take from I think both of you on this. In my mind, the ideal percentage of end-to-end tests, I don't know if that's the question, but as a percentage of your entire test suite should be 0.
Agreed.
But that assumes that you have a test suite.
Yes.
If you have 0 tests, then 100 end-to-end tests is better than no tests. But so here's the way I look at it. Every end-to-end test is a smell.
Yes.
And in a perfect world, we would eliminate all of them and replace them with lower level tests, whether somewhere lower on the pyramid. And basically every test that's above the base level of the pyramid is a smell. The higher up, the bigger the smell. So in a perfect world, we would go as far down as we can. We don't live in that perfect world most of the time.
Yeah.
And it's okay that we don't. But my point isn't to feel bad because, oh my gosh, we still have some end-to-end tests in our test suite. That's not the point. The point is, when you have the opportunity, replace those with lower level tests. And if you don't have the opportunity because other things are more important, that's okay too. But so we shouldn't aim for we don't have enough end-to-end tests, let's add some more.
Yes,
that's a silly goal.
Agreed. That's a silly goal. End-to-end tests should be ideally 0. Like if you have a lot of you can have tests which fall sort of into the end-to-end category, but they shouldn't be asserting behavior. They should be asserting a non-viable deployment artifact, right? That's a smoke test. All end-to-end tests are usually used as smoke tests. Regression tests are smoke tests. That's why we use them. But it's very hard to Google this. When I was doing research on my 7 types of tests article, and I'm writing it in chapter form for my book, a lot of people don't know what smoke tests are. I would really recommend you in the audience, if this is confusing to you, check out 𝗬𝐻𝐼𝐴. It's a PHP plugin for e-commerce, and it's really old. And in the beginning stages, like 15 years ago, it was shit. Like the ecosystem, the engineering quality was really bad. And they've improved it. And I would urge you, go to their pull requests. Everything is public. Everything is open source. Go to the pull requests and look at the closed pull requests and look for build pipeline, smoke tests, unit tests. Look at the history, the forensics of how they introduced testing into a large, complex, badly coded legacy system that had no tests. And a lot of their primary, and I had a coaching client on this, which is why this is top of mind for me. I have a coaching client who works in that PHP ecosystem. I always say, you want to do TDD? Great. You don't have any tests right now? Great. Start with smoke tests. Yeah. Don't do developer tests because you do not have any evidence that you are capable of decomposing behavior in your system. It's possible that everything that is written right now actually prevents you from decomposing behavior. So in order for you to write your first, you can write something new, like a greenfield microservice, and tack it on and smack it on the architecture and call that a success. But that's bullshit. Most of your hard legacy, the really valuable code, is in that messy part of the code base. And in order to write your first developer test that is isolated, fast, and reliable, and deterministic, you will have to refactor that system before you are able to write a new test for it. Which means the smoke test will help you see whether you made a catastrophic error. And that's where you want to start. You want to start with the part, and Kent mentions this. Testing is primarily about that, those first two. Can you follow this process confidently? And can you do it in such a way that verifying that the pieces, the way they connect, actually create a working system in the end? If you don't have behavior decomposition in your system, if you're only thinking about it as a whole, then work on the confidence first. Create smoke tests. And most smoke tests are written using end-to-end testing tools. But it's really important that you don't do this thing. What makes an end-to-end test flaky? You create the test, you spin up the real database, you add a lot of fixtures to the database, you spin it up, you log in with some test username and password, you click some buttons, and then, God forbid, you go check and you go route to another page and you check what's in the database and you make some really hard assertions about the overall state of the system. That's an end-to-end test. That's flaky. Because when that test fails, you have no guarantee that it didn't fail because you forgot to configure some of the underlying subsystems, or because something failed, or because there was a version bump on the SQL driver and now something's being, one of the big int types is now a string, no longer a number, and it overflows, right? So the problem with end-to-end tests is that when they fail, you might be tempted to say, "Oh no, that's just our staging environment sometimes being flaky. Run it again." That's the problem with end-to-end tests, right? So you should only have smoke tests that have a single assertion. When I go to this page with that set,
this is what I meant in the beginning. Don't.
When I see, right, so you just test for presence. When I go to the checkout page, I see the PayPal button. It is of this shape, and it is coming from the PayPal production website. It is definitely not a fake that I've put there to make the test pass. It is coming from the PayPal website.
Yes.
When I click it, an iframe opens. I don't care what's inside. It just appears, right? So it is operational. The checkout is operational. When I go to the website and I'm not logged in, this text shows up. I don't care why that happens and how that happens, but I see that at least this expectation is operational. If it's not operational, that smoke test fails, and it tells me that this deployment artifact is not viable for production. And that's where you should start if you don't have any tests. Jonathan, you mentioned, Adrian, Jonathan, any comments on this before we go to what?
No, do we want to?
Yeah, I don't discredit end-to-end tests so much as you both do, because I think that end-to-end tests, I only know one scenario myself, which I experienced myself, where an end-to-end test is not necessary, and but doesn't mean that we don't use it. Still, it is when you own backend and frontend in the same monorepository with the same people, the same team, in the same CI/CD pipeline with the same feedback response and the same team around that, or business around that. There you can basically just from bottom up test everything and be sure that you don't need to have an integration test. So the front end doesn't need to make sure that the backend is doing the stuff correctly, because the backend is already checking this in full maturity and responsibility and ownership, and the front end does so the same, and we have interfaces in between. Especially when you go, which we don't have, something like TRPC, then it's even less of a problem. If you have something like GQL or GraphQL, then it's actually a good thing to do as well, or even OpenAPI. The point is, I would even then think of an end-to-end test, just because of another aspect, because the end-to-end test does cover something the tests don't cover, which is the totally subjective side of things. So you expect things to happen in a way. For example, in Cypress, you can run against the Safari browser, which you, and if you, for example, and the problem is, so I am a front-end person. I know you both are more back-end related persons, and in front-end, the environment itself is already flaky. So if you write your test, if you write your component test inside, so for example, you write yourself a little drop down, so something which pops out, and suddenly in Safari, it is basically not popping out because it is somehow it is cut somewhere, so it is not there. In all other browsers, it is there, but in Firefox it does have a little bit more padding, and in Chromium it actually looks good. So how do you test that? And on some point, you need to make sure that your system is still viable, because I had that today. A client said to me in a fellowship, said to me that the clients, the real clients, ask them if they have tomatoes on their eyes when they test, because hey, it obviously I can't even open the system.
Yes,
So,
because
you
they
know,
compose the unit
you don't
tests,
need an
but they
end-to-end
never
test for that.
integrate. I agree, and that's where I disagree with Adrian. Yes, that's exactly that. You don't need an end-to-end test for that. An integration test is enough.
All you need is your front. You need to render your front end stuff in Safari with the test running.
That's true in this small case, but the point is that an end-to-end test, when you do it right, is not much of an overhead, but gives you a lot of information about the system. Something which you might not see with the things. In an ideal world, I agree.
If you have an incredibly simple system, maybe. But like even using your example where the front end and back end are maybe built by different teams, you don't even need an end-to-end test for that. What you need, now I haven't seen this done in practice very frequently, but what you need is a contract test, and you could run your the front end team, for example, could run their contract test against every new version of the back end code before they deploy, to make sure that the new back end meets their expectations. You could do that independently from an end-to-end test.
But the end-to-end test is not an API test. I think this is.
Let me show you, because it's great to talk about this in theory. I actually spoke on this at length with one of my clients, and they had exactly this problem, and I showed them an example of how WooCommerce does this. So this is a report that is part of WooCommerce's CI/CD pipeline. This is a result of 10 years of testing, and these are the smoke tests, right? And what do these test? Look at it from this perspective. It says admin marketing overview. The marketing page, number 1, a user can view marketing overview page without it crashing.
Yeah.
It doesn't talk about behavior. It just says, you know what? Every now and then, for an unknown reason, the overviews page crashes, and we want to make sure that if we can detect the crash, that we don't deploy that artifact, because people have complained that if the marketing overview page crashes, their marketing team panics and they don't want to install, and they do crazy shit to get around it. So we should test for it. And the beautiful thing is, like, look at their assertions. They just say, before hooks, give me a picture for content, give me a picture for the page, go to the page, expect it to be visible, and then destroy it. And what you can see is that you can see how long it worked, where there were any retries, and even for the types of tests, let's say where they fail, this one fails, for example, the color picker fails, and because the color picker fails, it somewhere has, I don't know where it is, select color picker. This one failed in Chrome, so I don't see it in. I think I'm showing you the wrong. Yes, where is the?
Yeah, but as we need to be sensible for time.
So here it is, right? So it has a hook. When it fails, make a screenshot and make a video of the test.
Yeah.
Or rather, it makes a screenshot and makes a video of the tests, and if all the tests pass, delete them. And it keeps the video and the screenshot if the test fails. So the beauty of this kind of smoke test is that it doesn't really capture behavior, but it says, hey, test, we have evidence of us accidentally breaking this page, so smoke test it, and if it does break, make a screenshot of it so that we can verify what might be wrong. Because it'll help somebody else not having to spend hours trying to reproduce the issue. It helps if you just show us a screenshot of the issue. That's my point. And this smoke test is created using end-to-end testing tools for the very reason you mentioned. They want to smoke it out in as many browsers as possible because they know that the environments are chaotic, and they just want to smoke it out as fast as possible to check things that they don't know. They didn't go explicitly and said, I'm going to create the UI for Firefox, I'm going to create the UI for Chrome, I'm going to create the UI for Safari, I'm going to create the UI for Opera, I'm going to create the UI for Edge. Of course, they haven't done that. So that part is composed. But obviously, it's such a complex landscape. Browsers are a complex API, and they have state as well. And if you're doing it in PWAs, then you have the over the wire and the over the wire state and the synchronization state and how much disk space you have left and what state the battery is on your phone. That it doesn't give you confidence that it works. It just tells you, hey, we shouldn't deploy this artifact because one of the smoke tests.
But this is what I mean. You need to have this feedback when you, especially, so it is a little bit about, you have time constraints, you have other limitations.
This isn't necessarily an end-to-end test. That's my point. This is possibly set up with a completely unrealistic environment. It might just be component mounted. It might just be page mounted on a fake backend, right? So I'm not saying this has to be end-to-end, but it is some form of integration test that is being used as a smoke test. Why is it a smoke test? Because it doesn't assert behavior. It asserts the absence of a problem.
Yeah.
And if you don't make it an end-to-end test, if you narrow it down to some form of integration test with a virtual service or with headless mounted in different browsers, you already get the benefit of the end-to-end test without the complexity and the flakiness of the end-to-end test. All right. So for all of you who are asking, have you really read WooCommerce pull request? Yes, of course I have. I do a lot of GitHub forensics for this very reason. But it's very easy. On GitHub,
you have a lot of time.
You go to close pull request and you just say build pipeline, smoke test, end-to-end, and you will just find the oldest from 2014, 2016. When they started adding the pipeline, then you can figure out what they really struggle with. And the first test they added were smoke tests because their code base was not testable. And no engineer on the team had experience testing their code base because it was really hard, right? So they had to build that confidence.
But again, I'm still not convinced to remove the overall idea of having, however we want to call them right now. I like to have at least a bare minimum coverage of the stuff QA persons would test or users would test and expect, because there is the point where really damage things. So if you have something up and running, and we're talking about software, so my part is never only about one specific part. So I always had the entire application in mind, the entire process, and you can't cover every case just with unit or component tests. It's simply not possible. And you will always have those little things in between. And the point is, end-to-end tests turned out for us, for our company, for years now, to be extremely good in covering that, as you said, this is not viable. And if in the first moment you don't know why, but you have the chance before it goes live. And this is one of those reasons why we have a system in between production and the actual trunk system, which is automatically deployed, but a little bit asynchronous. So it takes a while until everything is done. But we can integrate
staging server that integrates, and then
once we integrate several times a day to production, but basically constantly onto some system in between. We call it sometimes staging, sometimes development, which is constantly integrating the changes of everyone of trunk, and
it's
then
for people who don't have a local development setup to be able to open it up before it actually
exactly. But continuous deployment, so not the delivery idea, but the deployment idea, is only doable when you actually succeed with the smoke test, the end-to-end tests. And if those don't go through, you can't, because we add sometimes like those binary assertions to that when we have reports from let's say product owners who say, but we need to make sure that this part doesn't fail anymore. Right? And then you assert that specifically. You don't care if this is tested or not tested. It is This test covers it. And of course, you need to do this in the behavior part as well. You need to do that in the components as well. But and this is, I'm not talking about the engineering standpoint right now. I'm really talking about the business standpoint, because it hurts the business and the image of the company and the engineering team. And then again, if you run constantly into problems, you can't really tell why they happen. And this happens in basically every type. So sometimes where you really need to have a lot of contract tests because you don't have control over the APIs. This is extremely dangerous there. But even in environments where everything is inside your own repository, inside or your own team, even there we are only humans. We make mistakes. And I think those end-to-end tests, and I agree, maybe we haven't mentioned or put this out clearly, end-to-end tests should not take the role and the job of component or unit tests.
Absolutely. Because otherwise they're just shotgun tests, right? Because that's how a lot of companies do end-to-end tests. They use it as a shotgun, as like a spray gun, right? So we'll just create a large test suite that will accidentally test a lot of features as it runs through once. And that's shotgun testing, right? But the problem is that only covers like a really infinitesimally small percentage of all the things that can go wrong. And when it does go wrong, it tells you nothing about what needs to be fixed, right? So it doesn't actually, developer tests and contract tests, smoke tests are really helpful because they tell you, we're not going into production because X.
Yeah.
We're not going into production because here this behavior is not malfunctioning. And it tells you which piece of the code is malfunctioning. Whereas on the end-to-end test, if you're looking at it in the browser, what you might get is a screenshot and a URL. And then you need to reverse engineer, okay, which component is that? Why is that happening? How do I need to set up my user so that happens? Right, so that's already the equivalent of getting a synthetic bug report from a user. And it takes just about as much time to actually debug and reproduce and actually figure out, okay, was it a real problem? Is this something we missed? Is the problem in the way the end-to-end test is set up? Is it an unrealistic expectation, or is it actually broken? Is it always broken, or is it flaky? Right. So that's my, let's say, hesitation with praising end-to-end tests as much as you do. Although for some of I've seen your code base, some of your end-to-end tests I wouldn't call end-to-end tests. They are smoke tests or they are integration tests. But it end-to-end implies production scale environment, and not all tests are like that. It is possible that you do have a fake in there somewhere, or a staging environment. It's questionable whether you can call in a pre-production staging environment an end-to-end test if the environment is heavily controlled. Right, so that's already.
Yeah, of course, you need to define the circumstances and the context every time. So you can't really say in every company this is, or every environment this is the same. So you need to make sure that you basically constantly improve that, no matter what. So for example, I know a company where the end-to-end tests are actually done by non-engineers. They basically extend their test. It's more like the acceptance test, this tool for the acceptance test people. And the engineers don't know about that. They just get the hint that their deployment isn't going through because
that's smoke testing. Yeah.
Yeah, exactly.
So
And
I want to reiterate something I said earlier. After this conversation you guys have had, every failure I find in my smoke test, I would want to codify in either a unit test or an integration test, something lower, and then fix it.
Yeah.
And if any failure I find in an end-to-end test, or actually, let me restate what I said earlier. Anything above the lowest level of the pyramid, anytime I find a failure there, I want to reproduce it in a lower level test and then fix it.
Yes, this is we agree on that. Yeah. So it is
in principle, assuming a stable system and a perfect universe, we could then eventually delete everything above that lower level. We'll probably never actually achieve that again. Let me reiterate that. I
think a lot of people like to keep those.
Goal, not a realistic state to achieve.
Yeah.
But we should be moving that direction all the time of moving these tests from the higher level to the lower level, and then eventually deleting the higher level tests. Eventually, maybe being never, but you know what I mean, right? That's the aspiration.
I mean, the issue is that you might actually use helpful smoke tests with end-to-end tools that are more lower level than unit tests. That's why I don't like the pyramid, because some smoke tests are extremely low level. Fair enough. So if I say, the domain. I go to this domain.
The concept of the smoke test and the pyramid are kind of orthogonal. I get that.
Yeah, right. Because I can say, I go to the website, I go to Amazon.com, and it returns 200 and a non-zero sized body. That is a very low level test.
Yeah.
Right? But it uses end-to-end tools to achieve that. And I might test that in
whether it's low level kind of depends on what infrastructure is running behind that API, right?
Well,
like
the intent,
it's lower level than your browser.
Well, yeah, but the intent is that I am testing integration, or maybe the presence or lack thereof of some cache busting mechanism, or maybe TTL timeouts, right? So that's we're testing a different part of the infrastructure there, right? So I mean, again, I'm using complex tools here that might be that allow me to cheat, that allow me to say, you know what, this is not reproducible, because you know what the problem with end-to-end tests is? The problem with end-to-end tests is when I have one large staging environment that was like stuffed like a pig with different fixture scenarios, and then one environment is being used for unchanging for like 200 different scenarios, and it has to be done one by one because the system is locked for each test.
That's
the
problem.
biggest problem.
That's a problem. I think more generally the problem with end-to-end tests is you don't control all the variables, and there's too many variables to track. And you just described one class of those variables, but there are many others. You could have network timeouts that aren't really related to your software. You could have, there's a million different
space issues, database not being provisioned correctly or on time, or a cold boot versus a warm boot, or cache
as your systems become larger and more complex and have more moving parts, you might have components that have upgraded without your knowledge, or all these sorts of things. Now, it's important to make sure that your system works under those various circumstances. So still, these can be valuable to discover problems, but then you once again want to codify those in lower level tests, and given a set of known components, you should be able to do all your testing at low level tests. For
example,
I have the same confidence.
I can write a TypeScript React Next.js application, and part of the build step is compiling it to JavaScript, and an end-to-end test is a really lousy way of testing did it compile correctly, because I can do that step in a developer test on the unit testing level. I can compile it and see, okay, did all the entry points compile correctly? Did all the entry points export the correct things?
I think the bigger point is that an end-to-end test is a lousy test for anything.
Yes.
Any individual thing.
It has too much signal to noise ratio, right?
Yes.
So
that doesn't mean
the noise is so enormous that it only tells you something's wrong, but it doesn't guarantee that it is correct. It also doesn't guarantee that it is wrong, which is what
which is the reason why the end-to-end test should not be part of the development process.
Correct.
And this is so maybe we should put it in context, and suddenly the end-to-end tests are okay again, because there are another tool, another measurement implemented in the software development cycle, but not in the actual I make a change, I work on a ticket stuff. So this must be covered already by the low-level tests, and this is for sure. I think we all agree on that.
The end-to-end tests speak about lack of acceptance on the viability of a release artifact, right? So after everything's done, okay, can we release this? Is it deployable? Yes, we did deploy it. Can we release it, right? So is there something that we missed? But then, as Jonathan said, every bug report that comes as a response of a failing end-to-end test should then be translated. Like the procedure of fixing that problem should result in what he calls a lower level test, right? So a developer test, a contract test, a smoke test, an integration test, depending on what it is. But I wouldn't necessarily say lower level test. I would just say a non-end-to-end test, a more specific test, right? So
when I say lower level, I'm talking specifically about the pyramid, right? If you discover a problem in an end-to-end test, at minimum, create an integration test that proves the same problem and then fix it. If you discover a problem in an integration test, go one level down and re-implement that failure in a lower level, in a unit test.
Yes.
Assuming 3 levels of the pyramid, right?
Test it in a way where you can deterministically make it fail, and then deterministically prove that you have now stopped it from failing. That's the idea.
Yes, but I would go a step further from just deterministically, but as low level as feasible.
Fast. And cheap to write and cheap to debug.
Yeah. I mean, I might be able to deterministically prove it while I am connected to my live database and my Redis server and whatever. Maybe okay, I found a deterministic case. Now, how can I remove some variables from that so that I can deterministically prove it with fewer mocks or fewer components in place? Get lower level.
And sometimes it needs a more complex test, right? So sometimes an end-to-end test is flaky, and because you might have 1 in 100 page loads fails for some unknown reason.
Maybe it's a race condition or something, right?
Maybe it's a race condition, and you might have a simulation, right? So I also mentioned that sometimes Monte Carlo simulations are part of SLAs, right? So you might say on 10,000 page loads, the P95 should be above this threshold. Right, so the end-to-end test might sometimes fail, sometimes pass, but then you would replace it with a higher level test, an entire simulation, but on a much narrower scope, which is
so one of the open source projects I maintain has a bug report that's it's apparently a race condition that happens under load in certain circumstances, and so one of my goals is to write a test that will prove this problem exists. In isolation in the unit test suite, and it's very challenging.
And it's statistical.
I spent an entire day on it the other day. I need to work on it some more. But this is the sort of thing. So I can reproduce it in production when I'm talking to MySQL, or I can't, but the person who reported it can. And they think they have a fix. I'm not convinced of the fix, but I think it might just be glossing over it. But the point is, we know the bug exists. We now, and it was discovered. I don't know how it was discovered, but let's assume it was discovered by an end-to-end test. It was discovered. Now I need to codify it in a low-level test that is reproducible and in isolation. I don't want to have to run MySQL to prove that this bug exists.
Yes. Unless the issue is in MySQL.
Well,
you wanted to
possible.
You wanted to discuss, should we test private methods?
Do we have time for that? I don't know how late you want to run. I mean, I need to get going for too long.
We can touch on it.
I don't actually. I don't actually.
I do. I have 10 minutes.
Maybe we should discuss it next time.
Let's do it next time.
Yeah, because I think it could be a long, interesting discussion.
Okay, let's do that. Let's do that. So you just invited yourself to the next episode.
Well, it could be on my channel too. It doesn't matter. Either way.
Okay. But let's set that up. So today was all about test composability, and particularly behaviors of what the heck are we testing? Are we testing, the whole system? Are we testing a small piece? How do we split those small pieces apart? We were a bit abstract. I hope the conversation, the article that we read from Kent Beck was of use to our users. I saw that the viewership went up towards this later stage of our discussion, so that was interesting to see. Thank you all for those of you who have participated live. Kaloyan, you've been the most active and the first commenter today, so thank you so much for being with us. You're also a regular, so I appreciate it.
The first commenter was a bot.
First commenter was a bot, but at least a human. He was the first human. He was the first human that I can smoke out to be a human. Right. I did talk to him. Unless he's like a really good deepfake, but at that point, simulation theory kicks in.
He's an android,
all
actually.
All really good deepfakes.
This is all the Matrix, yeah.
So you can find Jonathan on the channel below. That's his main YouTube channel. It's possible that our next discussion will continue there, and I think it will be interesting to discuss private, this idea of testing private methods. Should it be permanent? Always, never? Good, bad. In a similar vein as we did with end-to-end tests. I'm glad you mentioned it, but it wasn't on the agenda for me.
Just as a like teaser, the conventional wisdom out there is never test private methods, right?
Yeah,
and I hear this as dogma from a lot of people, and I'm curious to hear your take, and I want to discuss the pros and cons. And
I'm like, go test your private methods as much as you want, because it's a sign that the private-public interface is not where it should be, right? So it's possible you need to test a private method.
You're doing next episode already.
or just go for functional programming and forget about this topic.
You should test your private methods. Here's why. And see you next time.
All right.
Jonathan, do you want to do a quick pitch on?
On Boldly Go. If you're interested in Go programming, Boldly Go is a web a channel and a daily newsletter about learning Go. If your team uses Go and you need some help, I'm also available for hire. 𝗪𝗵𝗲.tech is the place to find all my contact details. And to sign up for the daily list if you're interested.
Very recommendable.
Yes, I love your content, and the Star Trek themed Boldly Go channel is amazing.
Yeah, there's so many puns available for Go. I finally settled on a Star Trek pun.
Adrian, quick pitch from your side. Just putting your links on screen quickly.
Yeah. What I'm doing. So lately I'm writing a lot. Actually, I'm not doing so much LinkedIn anymore. But the background is I'm there to help companies, especially companies, but the teams as well, to get back on the correct track. So it is a little bit like I learned a lot in my past. I made a lot of mistakes. I paid for and still paying for my mistakes. And I try to help others with this now 2 decades of experience and not run into the same traps as I did, or pitfalls, and don't fall on the face like I did. And I try to translate what happens on social media, on business social media, on blogs, into what's actually necessary for small to medium-sized businesses. So primarily small businesses, because this is a very special context, as you heard today. And this is where I am helping. So if you're a startup, if you're a traditional company, try to become cloud native, try to adopt a continuous delivery, TDD or something like that, I'm there to help, not just to help how TDD works, but why. So what is the difference? How can you actually apply that? Why should you do that in order to fix what problem in your company? So it is about the entire vertical, but with a focus on the strategic and tactical part. Not so much. So I'm not the coach for the actual developer like Denis is, or maybe Jonathan. I'm more there to help the company, the heads of the company, the team leads, or teams in general. This is the lowest thing I do. This is what I do. So Raul is there today.
Hey, Raul. Adrian, mistakes are not the same as consequences.
Yeah, but mistakes leads to consequences. So, and this is the consequences, and this is the
I
reason.
think you responded to your comment about you're paying for your consequences and not necessarily for the mistakes. Although,
yeah, but it is the idea behind is the same. So you don't understand. One of my first videos I've created was hidden strategic decisions, and everything we do, if we do testing, if we don't do testing, how do we deploy, how do we act on, or which methodologies we actually use, or how do we practice. This all are decisions we do, and oftentimes we don't think of them as decisions. The problem is they are long-term decisions. There are no short-term decisions when it comes to the tactical strategic layer. You always do decisions long-term, and this is where I help when you have done the wrong decisions, or if you want to prevent doing those. And this is where I translate what you can read and what is really necessary for you. Because if I scroll through a LinkedIn feed, there is a lot of stuff which you shouldn't follow, because it's contextless. It's free of context. It is all about context, and if you're in a small business context, there are different rules for you, but you should aim for some specific things above your context. And how and why you should understand this is the reason why you should watch the stream or read 𝗪𝗵𝗲, which is the blog. And it's about that. So it's about engineering and not staying in your context, because the small business context is dangerous to stay, stressful and destructive. You need to get out of there and adopt practices from a more engineering approach. And this is what I try to teach.
Awesome.
Okay. Quick pitch from me. I work primarily with tech leads, team leads, whatever that's called in startups. That's usually the CTO. I'm a life coach with a heavy engineering background. So what we work on primarily is how to get confidence, a culture of engineering excellence, a culture of engineering quality, of deliberate practice into your engineering team. Generally, this is engineering teams or leaders who got stuck in their career or got sort of stuck in a loop of we're not making any progress, or tech debt overwhelmed us, or we don't have tests and it's hard to teach them, and everybody talks about tests, but we never do anything, or just constantly reverberating interdepartment setups, incomplete communication flows, lack of feedback, no truth seeking, right? So working off of hunches and estimations and guesswork rather than creating feedback loops, hard data, making incremental progress with the actual user on actual value-driven software, rather than what you thought is this sort of more traditional self-taught way of engineering. So I work with a lot of tech leaders who want to take their themselves or them and their entire team to the next level. So I work individually and with businesses. LinkedIn is my best way to sort of start building a relationship and to see whether this is a good fit for you. But you can also, if you already decided that you want to do something one-on-one, the Mentor Cruise link that you'll find in the profile is your go-to place to start a conversation with me and to book an intro call. The intro calls are free, so that's the best way to see what is the best next step for you.
Jonathan, do you still borrow your brain?
Yeah.
Not borrow, but offer to borrow, being borrowed by someone else.
I borrow my brain all the time.
Yeah, it's Borrow My Brain is still on my website. The last one I did was a few months ago. I used to do a lot more of them.
Awesome.
Yeah. Basically, borrow my brain for an hour, and I'll answer your questions, talk to you about whatever you need help with.
And that website is jhal.io, right?
That's right.
Okay.
I can recommend that. I have done that, I think 2 years ago, 2 times.
Yeah, you borrowed my brain a couple times, I think.
I still know the color of your brain.
Oh.
Then I needed to pass it back to you, and then...
Gentlemen, thank you a lot. Jonathan, thank you for...
It was fun. I thought it would be about 20 minutes. It lasted...
Yeah, me too. I'm very sorry for not putting your face on the
It was
thumbnail.
2 hours and 20 minutes.
I will fix it in post-production. I will create a new thumbnail where you're fully featured and highlighted. So sorry about that.
Fine. It's fine.
There's a very hot joint.
Hot joins with hot takes.
We will be continuing this conversation regarding private testing and sort of going into more of the technical weeds, the more unit-oriented, developer-oriented weeds of behavior testing. For now, have a lovely weekend. Thank you for being with us live. I think we had like 30, 35 people.
And we have a stream tomorrow, 12 o'clock. Because
yes.
there was no Wednesday stream.
Yes, so we were all a little bit sick and we moved the Wednesday stream. So first of all, the numbering got fucked up. I'm now on odd numbers. I used to be on even numbers. So today is 31 and tomorrow 32 for the first time. Adrian's Wednesday stream on a Friday.
I will announce for next week as well another day than Wednesday, because I have a speaker gig next week on Wednesday, which makes it impossible for me to stream on this day. But I will find I don't know if it will be before or after Wednesday. Maybe on Thursday. There's no, we don't do it on Thursday.
Awesome. So tomorrow at noon, the day is different and the hour is different. So noon Central European summertime, and I think most of our audience is in the same daylight saving, other than India. Indians, I'm sorry, your daylight savings are quite complicated compared to ours, or simple, depending on how you look at it. So I didn't do any upfront time zone conversions for you, so you just have to figure it out. So anyway, it's 4 hours earlier than you would expect us if you're in the same daylight saving regime.
It's about PaaS, by the way, platform as a service.
It's about platform as a service, yes. And it is one of a multi-part episode. So there will be a theoretical and there will be a practical one. Tomorrow is the more theoretical one.
Yeah, that's true.
Awesome, gentlemen.
Yes, then let's go now, I would say.
Have a lovely evening.
Live long and prosper.
Live long and...
I don't know how to do it with my right hand. Only my left.
It's a trap.
Cheers.
Some people will get that. Ciao. Some elevator music. We're signing out. See you then.